Okay, so we're back, SAT Prep Math. We're going to give you this is just square root practice for tests and for class in general. Whenever you see the square root of 5, well, let's start again. The square root of 5/3, and you see it over a bracket like this, and the whole thing is kind of elongated here. Keep in mind that you can break this down and then just make it a regular fraction. And in general, when you get ready to rationalize, you always bring up the denominator. And you're bringing up the denominator because that's what cancels out fractions. If that's what cancels out, if you can. I don't know if you guys saw the video on the conjugates and not conjugating a verb, but the conjugates of this, but it's kind of similar. Since this is the denominator, you're going to multiply both terms by the square root of 3. So your first step is to take the fraction, leave this, and then you are going to divide both sides by the square root of 3. And that's what's done here. When you divide both sides by the square root of 3, you're going to get, and remember, these are two, this is the square root of 5 times the square root of 3, which is the square root of 15. And what is this here? The square root of 3 times the square root of 3. Put them all back under the same, and you get the square root of 9. So you're gonna take one whole thing here, combine it together. You have your multiplication sign here, this dot. This is it. Now 5 can't be broken down anymore because your squares are 5 and 3. Those are the only numbers that go into the that's the only that go into 15. If it was 18 or it was 16, that would be a different situation. But since you can't divide this any further. So now you have the square root of 9 down here, but the square root of 9 is what? It's 3. If you can get two 3's together and you can get them under the sign, they cancel out and they erase this sign. And so that's how you can get rid of it. So I'm just going to make a note here for you, but your answer is already there. And so your answer is the square root of 15 over 3. And give me a second here, and I'm just going to write this here. Divide both sides by, you can call it the conjugate, but it's really not, because it's kind of not the negative side of it. And when you do that, they call this rationalization. And when you take this side here, this side here, and so here your answer is correct. So hey guys, let me go over something quickly. I said that this, when I went over it on the last slide, I called it a bracket, but it's really not. This is a radical sign. So we're trying to get rid of radical signs, and not that it makes any difference because I did show you what it is for these purposes. It's a radical sign. And I may refer to it as when you're getting ready to multiply as it's putting things together under a bracket, but I do mean a radical sign. So anyway, you have 1 over the square root of 2. Please don't confuse some things. You want to take the denominator, which is this, and you want to take it and multiply it by the numerator, which is the top part, and by the denominator. And when you put them together, these radical signs do somewhat act as if they're coming together, as you would as a bracket. But let's look at this. 1 times square root of 2 becomes the square root of 2. Even though this does not have a radical sign, when it gets multiplied as this, it's the same as saying 1 to the square root of 2. But you don't need to leave that there, so you just go ahead and call this the square root of 2. And the reason you were looking at this negative square root of 2 times square root of 2 equals square root of 4. Square root of 4 is what? 2. Because 2 times 2, 2's can cancel itself out, and they come from outside of the bracket, or the radical sign, excuse me, and then you can just cancel this radical sign out, and that's what happens here. And here's your answer, square root of 2 over 2. It's the answer. Simple enough. Okay, and here were some more steps. It's called rationalizing, and I just want you to take a look at it. And it's the same thing. And I'm just showing it over and over again because this problem is easy, but it on a test when you're under pressure, it's made to look hard. Okay, so 49ers, this is radical sign, square root of 49 x cubed to the y. When you break this down, you kind of treat this radical sign as if this is one large hovering bracket that takes care of everybody. It's a radical sign, but the terminology doesn't really matter right now, just as long as you get the problem correct. It doesn't matter right now. Your teachers may want you to not confuse it, but for right now, we're just looking at what we do. So 7 times 7 is 49. That's a perfect square. So that means that this 7 and this 7, since they're perfect squares, can be taken under here. Go ahead and write these out. X times x times x, you write it 3 times because that's the number you have here. And y you only have to write 1 time. Now, if you want to get rid of this radical sign, let's see if we can. You can here, and you can take 7 out of the radical sign. You can take a set of x out of the radical sign because this x1 is 1x. Please do not put x squared. You need a pair, and this is a pair. And so they're no longer under the radical sign. Now these two guys don't have a pair. Do you know why? You can't cross under the radical sign, this x and y, and take them out together. So you can't do this. So you have 7x times square root of x times y. And how you say it doesn't matter, just as long as you get the answer correct. So they have to get left because they don't have a pair. Okay? No other x and no other y. Please don't confuse this, and please don't go so quickly on the SAT. You're rushing and you forget, wait a minute. And if you can, go ahead and start canceling things out, like this, canceling out the coefficient and the variables as much as possible so that you can do, in case you run out of time, you can do this. Okay? Now, this is the same problem, but you have y to the 6th. And I want you to notice that this is an even number. And you saw what happened when you had a variable with an odd number. So all of this would be under the radical sign. Everybody's one happy family, but some people want to get out. So they want to go camping. So this 7 once again goes out because it has a pair. This x goes out because it has a pair. This x stays, but guess what? This y has a pair. This y is pairing with this y, and this y is pairing with this y. Uh-oh. Square root of x, you're by yourself over here. You're going to have to stay home, stay under the radical sign. But guess what? These y's don't. So you have a set of y's here. Whoops, I'm sorry. That red x is here. You have a set of y's here, a set of y's here, and a set of y's here, which make this y to the 3rd. Let me go ahead and erase it and bring this y up a little bit. So you still have a radical sign, but you have this. People may say, how is that? And if you remember, if you wanted to do it easier, this means the square root of all of this. So if you wanted to go ahead and like divide, you would get y to the 3rd. But then you have to remember that you take them out. So that's why I go the long way and do all of this extra things so that when you're doing something you can cancel. It's up to you how you decide to do it, as long as you get it right. Okay, and then this is just me showing it to you again. We're at jacobitslearning@gmail.com if you have any questions. Thank you for watching.